Ever feel like you're pushing something to the limit? Like one tiny nudge and the whole thing could just, well, tip over.
We're talking like a massive stack of dishes teetering precariously.
Exactly. Or how about that last rep at the gym where you're just hanging on, that point of no return?
Oh, okay, I'm with you.
Well, get ready, because today's deep dive is all about tipping points. But not just any tipping points. We're going planetary scale.
Ah, so not just a broken dish or a pulled muscle. We're talking about the fate of Earth.
You got it. And we're not talking hypotheticals here. We've got research straight from the journal Science that lays out exactly which climate tipping points have scientists seriously concerned.
Okay, so we're diving into the deep end with some hard-hitting science. What's the game plan for this deep dive?
Today, we're going to break down what these climate tipping points actually are, which ones are most urgent, the ones keeping scientists up at night, and what it all means for you and me. Because let's be real, this isn't some distant sci-fi future we're talking about.
Right, these tipping points, once they're crossed, we're talking about potentially massive changes to the planet within our lifetimes even.
Exactly. Okay, so no pressure then. But seriously, before we go full on doomsday scenario, let's define what we even mean by climate tipping points.
Well, imagine a giant lever, right? But this lever controls a specific part of the Earth's climate system.
And these systems, we're talking about things like massive ice sheets, rainforests, those powerful ocean currents, they can handle some change.
Sure, they're adaptable to an extent, but push that lever too far and boom, the whole system flips into a completely new state. Kind of like, a light switch.
It's either on or off.
Exactly. You can't really have a light switch halfway between on and off, can you?
And that's the thing with these tipping points. This change can be abrupt and, more often than not, irreversible. Once that system flips, once it tips, it's incredibly difficult, if not impossible, to go back.
Like trying to unscramble an egg. Once it's cooked, not going back to that original state.
Okay, that's a disturbingly accurate analogy. So this research, it breaks down these climate tipping points into two main categories. You mind walking us through those?
Absolutely. So first up, we've got what we call the global core tipping elements. Think of these as the heavy hitters, the big players. We're talking massive systems like the Greenland and West Antarctic ice sheets. If these guys tip, well, the ramifications are felt across the entire planet, no escaping it.
Right, those are the ones we always hear about, especially in the context of rising sea levels. It's scary stuff.
Exactly. Then you've got what we call the regional impact tipping elements. Now, while these might not impact the entire globe as intensely as those global core elements, they still have absolutely huge consequences for human populations and those unique ecosystems they impact. And one prime example that always comes to mind, the Amazon rainforest.
The Amazon.
Yeah.
Okay, so we're not just talking about melting ice here. We're talking about a pretty diverse set of planetary systems. So let's break it down a bit. What are some of the specific tipping elements this research really focuses on, and what makes them so vulnerable?
Well, why don't we start with those massive ice sheets you mentioned? The Greenland and West Antarctic ice sheets. Essentially, these are mountains of ice, miles thick in some places. And the thing is, they're already showing really clear signs of rapid melting. And this research really highlights how, and this is the scary part, this melting, it creates a vicious cycle.
Warmer temperatures lead to more melting, which then leads to...
You got it. As that surface of the ice sheet melts, it exposes ice at lower altitudes. Problem is, this lower ice is naturally warmer.
So it's like a giant sponge that, once it dries out past a certain point, loses its ability to absorb water.
Precisely. And just like that sponge, the Amazon plays a vital role in regulating the global climate. It's a massive carbon sink, meaning it absorbs more carbon dioxide from the atmosphere than it releases. But if it were to transition to a drier, savanna-like ecosystem, not only would it stop absorbing carbon, it would actually start releasing it back into the atmosphere, further accelerating climate change.
It's like the Amazon is doing us this huge favor by sucking up carbon, and we're repaying it by, well, essentially killing it.
It's a sadly accurate way to put it. And this isn't just about losing a vital part of the Earth's natural systems. Millions of people depend on the Amazon for their livelihoods, for food, for water. The collapse of this ecosystem would have devastating consequences for them.
Okay, so we've got melting ice sheets, a rainforest on the brink, and I know there's another major player we need to talk about. The AMOC, that ocean current you mentioned earlier. I'll be honest, I always thought of ocean currents as pretty stable things, like they just kind of do their thing in the background. How does something as massive as an ocean current even have a tipping point?
You're right. Most people don't think about ocean currents much, but they're absolutely vital to regulating the planet's climate.
Mhm.
And the AMOC, the Atlantic Meridional Overturning Circulation, is arguably the most important one for us here in the Northern Hemisphere.
I remember you comparing it to a conveyor belt. What exactly is the AMOC conveying?
Heat, essentially. Think of it like a giant lung. It inhales warm water from the tropics, carrying it northward along the surface, which is what helps keep places like Europe relatively mild even at higher latitudes. As the water cools in the North Atlantic, it becomes denser and sinks like the exhale, flowing back south along the ocean floor. This continuous loop of warm water flowing north and cold water flowing south is what regulates temperatures across the globe.
Okay, so this giant ocean lung is keeping things relatively comfortable for us. How does that system reach a tipping point?
Well, as glaciers and ice sheets melt, particularly the Greenland ice sheet, they dump massive amounts of fresh water into the North Atlantic. This influx of fresh water dilutes the salty ocean water, making it less dense and therefore less likely to sink.
So too much fresh water could essentially throw a wrench into this giant ocean lung.
Precisely.
Okay.
And if the AMOC slows down, or in a worst case scenario, shuts down completely, it would have catastrophic consequences. We could see rapid sea level rise along the eastern coast of North America, dramatic shifts in weather patterns, including more extreme heat waves in Europe, and disruptions to the monsoon systems that billions of people rely on for food production.
Wow, it really drives home how interconnected all of these systems are. We're talking about domino effects on a planetary scale. But it all seems to come back to temperature. How much warming can these systems handle before they hit their tipping points? That's what this research is really focused on, right?
Absolutely. And it's where things get really sobering.
So just to put things in perspective, we're already at 1.1 degrees Celsius of warming above pre-industrial levels. That's getting awfully close to that 1.5 degree target we hear about all the time.
It is, yeah. And this research, it really drives home how much those fractions of a degree really matter. Because within that Paris Agreement range, that 1.5 to 2 degrees Celsius, we see the risk of triggering these tipping points just skyrocket.
So even if, and that's a big if at this point, but even if we hit those targets, we're not out of the woods by a long shot.
Unfortunately not. Even at 1.5 degrees of warming, some of these tipping points, like the complete collapse of certain ice sheets or those devastating coral reef die-offs we've been seeing, they become, well, much more likely. And at 2 degrees, that's where we start venturing into those truly catastrophic, potentially irreversible scenarios. We're talking about the potential collapse of the West Antarctic ice sheet.
And I know we've talked about this before, but just for everyone listening, that would mean
Right.
meters of sea level rise?
Exactly. Meters. We're talking about redrawn coastlines across the entire globe.
I feel like we need to take a breath for a second. Just let that really sink in. Meters of sea level rise. It's
Yeah.
almost unfathomable.
It is. And it's a stark reminder of why this research is so crucial. It's not about instilling fear, it's about arming ourselves with the knowledge we need to understand just how urgent the situation is, because hopefully that understanding, that knowledge, will lead to action.
Knowledge is power, right? But I imagine there are people listening right now who might be feeling a little overwhelmed. We've covered some pretty heavy stuff today, and it's a lot to process. So what can we even do with this information? What can we as individuals actually do in the face of something as massive and complex as climate change?
Honestly, that's the question I get asked most often. And honestly, it's completely understandable to feel overwhelmed, even powerless, when you think about the sheer scale of this global challenge. But here's the thing we have to keep in mind. Individual actions, when they're multiplied across millions, even billions of people, they can and do make a difference.
So where do we even start? What are some concrete steps listeners can take?
Well, reducing your own carbon footprint is always a great place to start. It really does make a difference, and it's easier than you might think. Think about your daily choices. How do you get around? What are you eating? How much energy are you using? Could you bike more? Could you walk to the store instead of driving? Could you reduce your meat consumption, even just a little? How about being more mindful of your energy use at home? These might seem like small things, and individually maybe they are, but they add up, especially when you consider that ripple effect, how your choices can influence those around you.
It's about sending a message, not just with your words, but through your actions.
Exactly, and honestly, Never underestimate the power of your voice.
Hmm.
Talk to your friends and family about climate change. Make it a normal part of your conversations. Let your elected officials know that you care about this issue, that you support policies promoting things like renewable energy, sustainable agriculture, climate justice. Vote for leaders who actually prioritize these issues. It all makes a difference.
Because ultimately, this isn't just about saving the planet. It's about safeguarding our own future and the future of generations to come.
Couldn't have said it better myself. We're all in this together.
Well said. And on that note, I want to leave our listeners with a final thought. We've talked about these tipping points and how many of them are, well, largely irreversible, like flipping a switch, right? But what if there was a way to slow that flip down? Buy yourself some time to adapt. What if limiting warming to that 1.5-degree target could actually allow some of these systems, things like the Amazon or those massive ice sheets, to stabilize, maybe even recover some of what's already been lost? It's just a thought, something to ponder. But it speaks to the incredible resilience of this planet we call home, even in the face of these immense challenges.
It does. And it just shows how important it is to keep studying these tipping points. The more we understand these complex systems, the better equipped we'll be to find those pathways for mitigation and adaptation.
Because the future of our planet and our own well-being, they really do depend on the choices we make today. So let's make those choices wisely. Stay informed and keep that conversation going. That's it for today's deep dive. Until next time, stay curious.